Hello, one. So we have another AMC 10A problem. So this was 2013, number 19. So we have a base 10 number 2013, which is last digit is 3. And then if you convert this into base 9, so we get 2676 in base 9. Okay, so last digit is 6. And for how many number positive integer b does this base like b? The last digit of that number will be 3. So basically, question is asking you. So when you write 2013, let's say this number is base 10. So when you convert into base b, so you are told last digit will be 3, and you have no idea about the other digits. Okay, so and then you have no idea about how many digits you will have either, right? And the question is asking how many values of b is possible. Okay, so these are the choices. So it's fairly a straightforward question, but at the same time, it's not really clear where you are gonna start with, right? But here's what I'm gonna ask you to do. Like, even though we have no idea about the number of digits that we will have in this number, so we already know one of those digits is just 3, which means b has to be larger than 3. That is something I know for sure. And you can go with like maybe 4, 5, and stuff like that. You can say, okay, if that's like 4, and what is the largest number of digit that you could have for base 4 to see if this is going to be equal to 2013 in base 10. So you can say 4 to the like 5th power or 4th power and see what is the largest possible number. As soon as you see that, you can see if that's possible, and then you can go with 5, 6, whatever, all the way to the like the number that you can actually come up with. So that is still a possible way to try, but it's kind of too tedious, and then there's no really easy way to determine when to stop, right? So which is why I'll do this a little bit differently than just checking those each individual digits. So we are told the digit, which is the unit digit, is just 3 on that base b. And I'm gonna call the other digit, maybe I'll call x1, like x2, x3, I don't know, but I'm gonna call xn. Okay, and then the last digit is just 3. So it does look like a bit complicated, but I hope that's not gonna be. So since I have no idea about the number of digits, so n could be 2, n could be 1, n could be 5, and stuff like that. So which is why I just want to say xn. So if you want to convert this number into base 10, so this is what we have. So we have n digit right here plus 1, which is n plus 1. So we start with the 0th power, 0 first, 1, 2, all the way to the last one. So that will be nth power. So the x1 times b to the n plus x2 times b to the n minus 1, and it will continue. And then xn times b to the first, and the last one is just 3 times b to the 0, which is just 3. And this is equal to 2013 in base 10. And this 3 and this 3 nicely cancel each other, so we can subtract. So if I do this, I will get x1 b to the n, x2 b to the n minus 1, and all the way to the xn b to the first equals 2010. So what does this do? This is really helping to see what's going on, because b and b to the n, b to the n minus 1, all the way to the b to the first power. If you pull those b's as a factor, so you will see b times x1 times b to the n minus 1, because I subtract one of these b's, because I just pull one of those b's, and x2 times b to the n minus 2, you will just continue all the way to the xn. We already pulled this b, so there is no b left over. So that's 2010. So what does that tell you? B is an integer, because that's my base. You multiply that base by a bunch of sum, right? And then I know x1, x2, xn, all of those are also integers, some digits. And then you multiply with the integer power, so which is why each of these guys are integer. So which means this whole thing is integer. Integers times integer is 2010. which means B has to be a divisor of 2010. So I just did this little more extra work, which is some people don't really want to do this much work to get that immediately, but I just want to make it a bit longer just to make it a bit clear. I hope that was clear. So which means B, which is the base of the number that I'm looking for, has to be a divisor of 2010. So since my last digit was 3, you could just subtract that 3 from 2013, which was to 2010. Then you could say that number, whatever number you have, like, I mean, base, like, because we are going to find some multiple of B's, like B to the first, B to the second, and stuff like that. So that means if you subtract this 3 from that number you are given, then the remaining number should be multiple of B, which means B is a divisor of 2010, which is kind of, I hope this is going to tell you why. Okay, so then let's go ahead and find the divisors, number of divisor of 2010. So I can just divide by 10 immediately, which is 2 times 5 times 201. And that looks like divisible by 3. So 2, 5, 3. And if I divide this 20 by 3, which is 6, 18, 21 will be 7. And 67 is a prime number. So all of these are prime numbers. So the number of divisors, okay, of 2010 is basically you just add 1 to each exponent. So you should be aware of that already. So that will be 1 plus 1, 1 plus 1, 1 plus 1, and that's just 16 divisors. So 2010 has 16 divisors, which means B could be a 16 divisor, and then 16 is one of the choices. But at the same time, I need to be careful because at the beginning I said B represent the base for the new number. And then since 3 is one of those digits, so it has to be larger than 3, right? And that means 1, 2, 3 is also divisor of this 2010. So we just need to subtract those 3. So that will give us the answer. And then some of you may ask you, how do we know all those 13 numbers are achievable? So this is another homework for you to explore if you can prove it. But I think that's a good valid problem to ask, question to ask. But that's, I guess, we don't need at this point. Okay, so that is the answer. So I hope that was clear, and I'll see you in the next video.